25. See. So in lecture 24, the topic was Introduction to Computer Vision. So this is one of the application. One of the primary AI application is computer vision, and that lecture was based on computer vision, how different computer vision application, what are the different computer vision applications and how it is done. Acha. If I share one thing with you, can you see the screen?
Yes, sir. Yes, sir.
So in lecture 24, so this was one of the figure I actually showed you. This is what a convolutional neural network looks like. Okay. So in a convolutional neural network, what do we have here? You see, this is the artificial neural network part. We have studied it in the last lectures. This is what a ANN looks like. Okay. And in terms, we also call it fully connected layers because all the networks, all the nodes are connected. That's why it's called FC layer or fully connected layer. And this is used for the classification tasks. Okay, fine. The problem with image data was that unlike our traditional structured data where the features are available to us directly, okay, we know the whatever the scenarios, we know the height, the weight, or the house location, etc. These are the features that are very clear to us. But images, the features are not available to us directly. So we have to go through some process. The process is called feature extraction. You have to extract the features through some process. Okay. That process is called convolutional operation. Okay. So this part in the figure that you see, this is the convolution operation that is happening here to extract feature from images. We'll see how this feature is extracted from an image, how we can actually extract feature from an image. That's the goal. After we extract the features, you see the flattened layer. These are the features that we have. For a zebra, there will be some particular feature. For a cat, there will be some other features. Based on those features, then you have this ANN algorithm, ANN network to classify it. Okay, this portion remain exactly the same. You have the features, classify. But how these features, we are getting these features, that the part we want to learn today. Okay, that's the topic here today. Any question? Acha. So we'll try to look into this one. We'll look into system sheet. Okay. So our topic today is actually CNN. CNN stands for Convolutional Neural Network. Okay. Convolutional Neural Network. All of this actually in part of deep learning. Okay. Or deep neural network. Acha. So in convolutional neural network, basically there are two stages. What are those stages? Number one is the feature extraction stage. And the second part is the classification stage. So the feature extraction, for the feature extraction part, we have certain operation. What are those operations? For instance, first you have the convolution operation. Then you have pooling operation. Then you will see ReLU. ReLU or activation, any type of activation. Activation operation. Then you have batch normalization. Batch normalization. Then you have fully connected layers. And finally, you have the softmax activation. So এগুলোকে বলে প্রত্যেকটা অপারেশন ইটস লাইক এ লেয়ার, কনভলিউশনাল লেয়ার। All these things together create our conv net. Okay. in short এটাকে বলা হয় convnet. Okay, this is what we use. This is primarily used for learning from image data. Okay. Now, the classification part is exactly the same as ANN. So just like I mentioned earlier, the same thing. So this is what you want to understand, how these operations allows us to extract this meaningful meaningful কি বলবো features. Okay, meaningful features or meaningful information from the images. আচ্ছা, so see, image. What is an actually an image? So if I say, let's say this is 0, this is 0, this is a 1, okay, this is 5, this is 8. So this is like when I'm writing this for you, this is like the visual perception. But for a computer, what do you have? Like if I call it like this, try to do it like this way. For a computer, it will be like what? Let's say something like this. These are all 1. The rest of the things are 0. Rest of the pixels are 0. Now think of it like this. Does it look like a 0 to you?
Yes, sir.
Okay. So for a computer, this is like only the pixel values. You have one or 0. Think of for binary, it's simple. Think of it like this. From binary, it is like 0 and 1. 0 means presence of some pixels or black or white like this. So any idea, any things, if you look at like this way, it is going to look something like this. So if you look at the pixels, the pixel values are going to be like this for a 1. Okay. So the rest of the pixels are going to be 0. All of them are 0. And the remaining pixels is going to be 1. So wherever you are the border, you have this 1 like this. So basically that's the information. So in image, the information is located in pixel values. The pixel value shows the intensity of color. Acha. Now, the question is how we can actually extract some meaningful features or meaningful information from these random pixel values. I am writing here 1, but what we use a grayscale image. In a grayscale image, the pixel values are from 0 to 255. So instead of 1, it will be some values, random values of 100, 200, something like this. 0 means completely black or opposite completely white, whatever you say. So that's the difference. Yeah. So the question that actually comes, that is actually how you can actually, from this random pixel value, I can extract some meaningful information. Acha. Now, before we go there, if you think of it like, if I try to do it using a simple ANN or artificial neural network, you see, since in ANN, we don't have any exactly way to actually extract information. So what do you have to use? The pixel values directly. Pixel values will be our input. Okay. So if I use the pixel values directly of our input, okay, so the input will look something like this. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. I am just flattening it. So the input is going to look like this. For 0, it will be something like this for 8, something like this for 5. Then you actually feed it to a set of other neurons. Okay, every value will be feed like this. This is what a neural network would have looked like. Okay, then you have prediction like this. Achha. The problem is, you see, if you flatten it like this way, there is no specific pattern. There are some pattern, but not very specific. Why not very specific? You see, there is no proper way to identify how the pattern is actually coming. So if you just simply flatten it, then try to feed it in NN neural network, artificial neural network, the score, the prediction performance is going to be very poor, not very good. Okay. Because you are not actually identifying any pattern, you are just putting the pixel values. Okay. So pixel values relative information is very low. So the performance is going to be extremely low. Another thing is that if you look at ANN, let's say an image is of size 1280 and 720. We use a grayscale image, so not the RGB image, we convert into a grayscale image. So that means there are how many pixels? If I multiply, this amount of pixels are here. Okay. Now, if you feed these pixels, this amount of pixels, that's the flattened layer size. If you put it in a neural network of, let's say, just 1000 connection, 1000 neurons, so the total amount of the size, the total amount of weights that you have to update, 00, তারপর কি আরো 3টে শূন্য. So that amount, that's extremely high quality quantity. That amount weights that you have to update on every iteration. Okay. So this just explodes. The computation completely explodes. Okay. Computational complexity completely explodes. So this is not suitable at all for image class. Okay. Any question?
Sir, image flatten, what does this mean?
বুঝি না, আরেকটু জোরে বলো.
What did you mean by flatten?
ফ্ল্যাটেন মানে হচ্ছে 2D একটা ম্যাট্রিক্সকে 1D করে দেওয়া. ওকে, তার মানে হচ্ছে ধরো তোমার একটা ম্যাট্রিক্স আছে এরকম 2 5 2 3 4 6 1 0 0 0. If you flatten it, it is going to look like this: 5 4 0 2 6 0 3 1 0. Okay, this is the flattened version. Just 2D কে 1D করে নাও.
Okay, sir.
আচ্ছা. So basically, when it comes to images, this is not a really a good way. So we have to think of other ways. So that's where our convolution operation comes. So what is a convolution operation? Acha. A convolution operation is basically a filter. We call it a kernel. Okay. You have a filter, you pass the filter, okay, pass through the image. You pass the filter through the image. Okay. So using like a sliding window technique. We talk about sliding window technique. So I have a filter. I'm going to pass it through the image with sliding window technique. You have studied convolution operation in DSP, I think. Acha. So when I'm passing, I am calculating the dot product from this sliding window, from every window. So what does it mean actually? How does it look like? Let me show you. So this is the convolution operation, okay. So I mean, this article is given to you, so don't worry. So basically, let's say this is your pixel values. Okay, একটু যদি ভালো মতো খেয়াল করে দেখো, what does this one value represents? বলো তো কোন লেটারটা রিপ্রেজেন্ট করতেছে?
9.
9. Yes, you see this is looks like a 9. So the 9s are, that means these are 1, and remaining one, let's say -1, okay, or 0, whatever you want to say. Fine. So that's the image, that's the pixel values that you have, and we want to perform a convolution operation. This is convolution size with this filter. This is what a filter, one kind of filter. There can be many filters. This is one filter, for instance. All the values, outside values are 1. The middle value is -1. What do? You take this filter, multiply. You start from the first box. Okay, 3 by 3, 3 by 3. You take the dot product. Okay, so if you take the dot product, this looks like this, -0.11. Acha. Take the average of it. Acha, fine, সমস্যা নেই. So you take the dot product, take the convolution operation, then slide it to the next one. So that should be like this, sliding. Are you following? Sliding to the next bit. And this is the summation that you have, average summation. Then slide it to the next bit. This is where next one comes. Then again slide it to the, go down. You start from here, then slide it again, then slide it again, and you calculate for every scenario. Is it clear? The sliding operation, sliding window technique?
Yes,
Any
sir.
question? Okay, so basically you take the filter, you perform this convolution operation like a sliding window throughout the image. Okay, throughout the image, you keep doing this. Okay, you keep doing this for everyone. Go one by one step by another step. So here the jump step is 1. So that means you are just going to the next step. Okay, fine. And this is the final. After the convolution operation, this is what you are getting. Okay, this is what you are getting. So this one is called a feature map or activation map. Okay, we are going to talk about it a little bit later, why it is called a feature map or convolution map. So after convolution operation, like one convolution operation, this is the output that you get. You see the original image was of what? Size 5 by 7, তাই না? Sorry, 7 by 5. After convolution operation with a 3 by 3 filter, size কি হয়ে গেছে? কমে গেছে না? The size has reduced, right?
Yes, sir.
Yes, because you are just convolution option, that means প্রত্যেকটা থেকে দুইটা দুইটা করে কমে আসতেছে, একটা করে কমে আসতেছে. So the size will be reduced. We'll see how much size will reduce later. So basically from the image that you have, the pixel values that you have, you perform a convolution operation like this. And this is the output that you look like. So now what this output looks like, if you be very careful on this portion, see, this is 1, right? These ones are negative. Negative আছে না? This is what? Positive. Positive না? Are you following?
Yes, sir.
Yes, sir.
আচ্ছা. Now, try to understand this one very carefully. So you see, this is what a filter looks like. Achha, let me write it down in a no. Sure. 5 by 3, I know. 5.11, 0.33 minus 0.33, 0.33 minus 0.33 minus 0.22 minus 0.11. Remember this calculation, I might have give this problem as a
Sir, are you writing anywhere?
yes,
স্ক্রিন
right.
দেখা
দেখাচ্ছি
যাচ্ছে
দাঁড়ান।
না
স্যার স্ক্রিন তো দেখা যাচ্ছে না।
হ্যাঁ দিচ্ছি আমি জাস্ট ইয়াটাই লিখতেছি। Okay, so can you see the screen now? This was the filter, right? So we perform the convolution operation, we get this one. Acha. Now, after this convolution operation, what we perform is called a ReLU. What was ReLU? মনে আছে? ReLU was a transfer function. What kind of transfer function? F of x যদি দেই, it will be between maximum of 0 and x. Okay, so what does it mean? এর মানে কি? So for any value, see, for any value, for max of, let's say for the first one, 0.0 and x, তাই না? Sorry. So the first one, this is actually 0, minus 0.11. So what this value is going to be, এটার জন্য ভ্যালুটা কত হবে? After ReLU?
0
0 হবে। ঠিক আছে? What about the next one? Max of 0, minus 0.55?
0
Yes, 0, because negative value. Then what about max of 0, 1? এই ভ্যালুটা, এটা কত হবে? 1. Okay. So আবার দেখো, max of 0, 0.11, এটা কত হবে? 0.11. So basically, if it is a positive value, it will be exactly the same. If it is a negative value, it is going to be converted into 0. So, ঠিক আছে? So, if we perform a ReLU operation on this matrix, this is going to look something like this. So all these values are going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. This is going to be 1, this is going to be 0.11, this is going to be 0.33. ঠিক আছে? Is it okay?
Yes, sir.
So Basically, when we have an image, I have first the convolution operation, then I'm performing the ReLU operation. After ReLU operation, the matrix becomes this. Okay, fine. Now, after this ReLU operation, we perform pooling operation. What is pooling? So one of the pooling is called, there are different types of pooling. One of the pooling, max pooling, mean pooling, or average pooling. আচ্ছা। Now, what is the max pooling looks like? That's the most commonly used maximum pooling. Or max pooling হচ্ছে, you see, if I take a 2x2 filter, so this is, let's say, 2x2 filter on this image. Again, the sliding window. The task is, what is the task? Whatever the maximum of this one, only that one is going to remain. Is it clear? The maximum of this one is going to remain. So if that is so, what is the maximum of this first block?
1.
1.
1. Then slide again, slide to the next block. What is the maximum of this block?
1.
1 আসলো। Then lower slide. What is the maximum of this block?
0.33.
0.33. ঠিক আছে? The next block is 0.33. Then you have 0.33, 0.33, and 0 and 0, something like this. আসছে না এরকম? Are you following?
স্যার এটা কি সবসময় 2x2 ম্যাট্রিক্সে পুলিং করা হবে?
No, the size can be different. আচ্ছা। So basically try to understand what is happening here. Now, when I'm performing this operation in the convolution operation, then the ReLU operation, think of the pooling একটু পরে আসতেছি, pooling ছাড়া আরো কিছু জিনিস আছে, এটা একটু পরে আসতেছি. Think of up to this one now, for now. So the matrix that you have, you see, most of those things are 0, but suddenly you have some positive values here, right? আছে না? Some of the positive values.
Sir.
আচ্ছা। So
Yes, sir.
So basically what we are doing here, what we have done here, our original image was 9. Okay. We have performed convolution operation with this one, with a filter like this or a kernel like this. Kernelটা ছিল এরকম -1. Okay. Then we perform the ReLU operation. Ultimately, we got a value something like this. That is 0, 0, 0, 0, 0, 0, 0. This is 1. This is like something close to 1. Something this way. If that is the scenario, basically this filter is called a loopy pattern filter. So what this filter is identifying, has it been able to successfully identify a loopy pattern there? করতে পারছে?
লুপি প্যাটার্ন বলতে কিরকম?
এই যে এটা হচ্ছে একটা লুপ. This is a loopy pattern. Is there a loopy pattern has been identified here?
নো স্যার।
হয়নি? Try to understand. Loopy pattern means if you have a circular block like this, the output filter is going to result in a 1. If there is no loopy pattern, it is going to be 0. Now think of it like this way. Did you get a 1 from after the convolution operation? আমার কথা বোঝা যাচ্ছে?
Sir.
Yes, sir. We got one.
So think of it like this way. আবার দেখাচ্ছি. If you have a 1 like this, okay, if we multiply with this one, এটা বাসায় বসে করিও. If we multiply with this one, okay, with a block like this, do you think we'll get a 1 here output?
No, sir.
There will be 0. So basically, এই জিনিসটা যেটা করতেছে লুপি প্যাটার্ন ফিল্টারের কাজ হচ্ছে, if there a loop exists, loop means like a circle exists, the output feature map, যে feature mapটা আমরা পাচ্ছি, in the feature map there is going to be an 1 and the rest of the things is going to be 0. আমার কথা বোঝা গেছে? Are you sure? Clear?
স্যার আউটপুট ম্যাট্রিক্সের কোথাও না কোথাও একটা 1 থাকবে,
কোথাও না
মানে
কোথাও একটা 1
কোথায় থাকতেছে
হ্যাঁ, কোথায়
Sir,
থাকতেছে ডাজন্ট ম্যাটার, বাট একটা
মাঝখানে
1
ওটা কি -1?
কোনটা? -1, হ্যাঁ। So if there is no loopy pattern, like if you have 1, if you have 5, then you are not going to get any 1 there. It is going to be 0. You can calculate by yourself. Calculate করে দেখিও, convolution operation করে দেখিও, it is going to be 0. আচ্ছা। Now tell me, if it is a 6, we'll have a loopy pattern here.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
If we have a 8, we'll have a loopy pattern here.
Yes, sir.
There will be not only 1, there will be 2. There will be 1 here, somewhere in the 1 here. আমার কথা বোঝা যাচ্ছে? ঠিক আছে না? Am I right? There are 2 loops. So there is going to be 2, 1. Are you following?
স্যার আমরা শুরুতে যে কার্নেলটা ইউজ করছিলাম সেটা কি লুপি প্যাটার্ন ফিল্টার ছিল?
Yes, that was a loopy pattern filter. If you pass it
বাট
along,
আউটপুটটা তো তখন এরকম ছিল না।
হ্যাঁ, output,
তখন তো আমরা এরকম পাই নাই, একদম শুরুতে যখন এই পিডিএফ এ দেখালো যে স্যার এরকম আসছিল।
আমরা এটা পাইছিলাম কনভলিউশন করার পর, তাই না?
হ্যাঁ।
তারপর আমি যখন রেলু করলাম তখন কি আমরা এরকম পাইলাম না? এখানে একটা 1 আছে না?
আচ্ছা, আচ্ছা, রেলু করা লাগবে।
হ্যাঁ, রেলু করার পর কনভলিউশন রেলু একসাথে, কনভলিউশন রেলু একসাথে, আর সেখানে এটা। So here you have a
Yes, sir.
1. আচ্ছা। Now, if you have 6, there will be going to be 1, but in the below side. If you have 8, there is going to be 2, 1. ঠিক আছে, একটা উপরে থাকবে, একটা নিচে থাকবে। Are you following?
Yes, sir.
Yes, sir.
So if you have this one, how many loopy pattern you are going to get?
3.
3.
3.
2, basically for 2 eyes. Okay, not the face. Face টা আসলে face এত ইয়াও হয় না। আচ্ছা, ignore the face. Basically you are going to have two. So that means that kernel that you just saw, that can be used to identify any loops or circles. ঠিক আছে? Are you following? These are called low level feature. In terms, this will be actually represent an eye. Represent করতে পারবে? চিন্তা করে দেখো, can it represent an eye?
No,
Yes,
sir.
sir.
Sir, actual
I
I to
think yes.
Our eye is a loop, right?
Yes, sir.
So if it is a circular loop, if you take an image of, so when it passes through an image, just because it is a circular loop, there is going to be an eye there. So there is going to be eye, there is going to be loop there. So loop means it is going to return an y. So basically this kernel, so that the kernel that I just used here, so loopy pattern filter যেটা, loopy pattern filter, this can identify the position of an eye. করতে পারে? It can be a little bit difficult to realize it properly. Okay, আর্টিকেলটা একটু পড়ে দেখিও, তাহলেই বুঝবা। So but that's what is actually happening here. If you try to understand properly, that is what is happening here. We are passing a filter like this. It is allowing us to identify something, and that one is going to be our feature. That is one feature. Are you following? So let's say if you have a tree like this, are you going to get an eye feature there? No.
No.
But if you have a human being, are you going to get an eye feature there? Yes.
Yes.
So that's how you actually differentiate. That's one of the feature that you actually extracted now. You see, previously features are not available to you, but now after this one kernel or one filter, you have some sense of feature available to you now. Are you following? Is it clear? আবার দেখো। Now, like this is one type of filter. There are many other types of filter. For instance, vertical line filter. Okay, what is a vertical line filter? So vertical line filter, I think the value is going to be something like this: -1, -1, -1, -1, 1, 1, 1. I think this is the vertical line filter. ভুলে গেছি। আচ্ছা, so হ্যাঁ, এটাই হওয়ার কথা। So if you pass this, if you have an image, if you pass through this মানে convolution operation with this vertical line filter, if there is a vertical line exists, this is going to return an 1 there in the feature map. Otherwise, it is going to be 0. Are you following? So let's think of it like this. So if I have a 8, after when you pass it through a vertical line filter, we'll have a 1 there for this kernel.
No,
No,
sir.
No.
No.
loop থাকবে।
If we have a 1 there, will we have a output 1 or 0?
One.
1
ভার্টিকাল ফিল্টার ইউজ করলে 1 হবে।
1 হবে। I have a 2. Now we'll have a 1 or 0.
স্যার
Zero.
1
Zero.
0.
one.
There is no vertical line. Are you clear?
বাট স্যার এখানে তো লুপি প্যাটার্নও নাই 2 তে।
So ওই জন্যই তো 0.
Oh, okay.
আমি এখন ভার্টিকাল ফিল্টার পার করতেছি।
আচ্ছা আচ্ছা
ঠিক আছে? If I put a vertical filter through there, I'm going to have something like this. Similar to vertical line filter, you have horizontal line filter. Okay? Horizontal line filter just the opposite one. ঠিক আছে? এগুলা হবে মাঝখানেরটা হবে 1, বাকিগুলো হবে -1 like this. আচ্ছা। So for a horizontal line for 8, horizontal line filter, it is going to be 0 or 1.
0
0. For 1, it is going to be 0 or 1.
0
0.
Zero.
For 2, it is going to be 0 or 1.
1
1.
One.
Because there is a horizontal line filter here. So what you are actually doing, you see, whatever the image that you have, okay, through that image, you are going to pass not just one filter, but multiple filters like this. Horizontal filter, vertical filter, loopy filter, এরকম অনেকগুলা filter. So let's say you are passing this image with 64 filter. So that means that image, let's say, whatever the image is, let's say 100 by 100 size. This is going to be like the third dimension. So the image that you have, the grayscale image, it is passing through 64 filters. That means the output is going to be 100 by 100 by 64. তার মানে কয়টা ফিচার ম্যাপ এখানে ক্রিয়েট হয়েছে বলো দেখি?
So could you explain that
64.
again?
64 feature maps. So the same feature, same image, it is being passed through multiple kernels. That one is like every kernel is creating a feature map. So that's what you have after one convolution operation like this. Is it clear? আমার কথা কি বোঝা গেছে?
So could you explain this last one again?
Last one. Okay. So you see, we are passing the image from different types of filter. Vertical line filter, horizontal line filter, because we want to identify different patterns. So an image is going to be passed through a multiple filters like this. So let's say this is your horizontal filter. Then you have vertical filter. Then you have loopy pattern filter. Then you have Bessel filter like this, many filter. Let's say 64 different filters. So each filter is going to return one feature map. So if you are using 64 filters, so 64 filter is going to return 64 different feature maps. Okay, so it is like a 3D matrix where every page of that matrix is a feature map. Is it okay? So,
Yes, sir.
so think of it like a book. A 3D matrix is like a book. Okay, where every page you have one image, the same image, and every image is like highlighted. What are highlighted? The features are highlighted. Okay, these features, these are called activation. এটাকে বলা হয় activation map or feature map or feature activation map or receptive field, অনেক কিছুই বলা হয়. Basically, the idea is whatever the image that you have, when you are passing this image through a kernel, for that specific kernel, certain feature is going to be activated. Just like we have seen, if it is a face of a human being, passing it through a loopy filter, the eye feature will be activated. Okay. So if it's 2 like this, and you are passing it through a horizontal filter, then due to there is a horizontal line here, so it is going to be activated. For this one, it is not activated. আমার কথা বোঝা যাচ্ছে? So each filter is going to activate something features. Are you following? Any question?
Yes, sir.
Okay. So basically,
Sir.
this is what you are doing. হ্যাঁ বলো, কোন কোশ্চেন?
স্যার ডিএসপি তে দেখছিলাম কার্নেল যখন কনভলিউশন করা হয় তখন হরিজন্টাল আর ভার্টিক্যাল ফ্লিপ করা হয়। এখানে কি
Horizontal আর
ভার্টিক্যাল ফ্লিপ করা হয়, তারপর
Vertical?
কনভলিউশন করা হয়। ফ্লিপ,
ক্লিপ?
জি স্যার।
স্যার মানে স্যার ভার্টিক্যাল ফিল্টারটাকে যদি স্যার ট্রান্সপোজ করি তাহলে স্যার যেটা আসে ওইটাই নাকি স্যার হরিজন্টাল ফিল্টার, মানে এরকম
হ্যাঁ
স্যার আমরা ল্যাবে দেখছিলাম এখানে।
হ্যাঁ হ্যাঁ ওইটাই তো। এটা
মানে
হচ্ছে
স্যার কনভলিউশনটা আসলে আগে ফ্লিপ করাই নেওয়া হতো, তারপর হচ্ছে কনভলিউশন করা হতো।
একই জিনিস, রেজাল্টের আলটিমেটলি তোমার সেমই আসবে, তুমি করে দেখিও সেটা মোরলেস সেমই আসবে।
আচ্ছা আচ্ছা।
একটু জাস্ট দেখে নিও, ফিল্টার গুলো দেখে নিও, কারণ এখানে ফিল্টার ভ্যালু নিয়ে আমাদের খুব একটা সমস্যা নাই, এটা একটু পরে আসবে। আচ্ছা, so basically আইডিয়াটা বোঝো, whatever we are doing, we have the image, we have the pixel values, we are passing some filters through it, and resultant we have some feature maps. Okay, for a specific type of feature filters, we have a specific feature. So that is like, these are the features that we have now. Now it makes sense, right? So we have many other things. Acha, before we go there, so basically if we look at the ওখান থেকে after convolution and value operation, okay, think of it like, if I have the image, I'm passing it through the convolution relay operation. This is the flattened matrix. Okay, so now you have something like the features. These are the features that you have. Now you have certain features. This is 0 means there is no loopy pattern. This is 1 means there is a vertical line. This is 0 means এখানে আর কোনো কিছু নাই. 1 means there is a horizontal line like this. So the features are now activated. Okay, so this is the like the basic concept of convolution operation. When you are performing a filter operation like this, some of the features gets activated, some of the features, if the feature does not exist, that feature is not going to be activated. That is why it is called a activation map. Okay, acha. Any question up now? We are going to go further. আচ্ছা
স্যার এখানে পুরো ফ্ল্যাটেন হয়ে গেল কিভাবে, মানে একটা কলাম হয়ে গেল পুরো?
আচ্ছা, ফ্ল্যাটেন্ট হচ্ছে যে একটা ছবি দেখাইছিলাম, একটু পরে আমি আবার আসতেছি এখানে, ফ্ল্যাটেন আবার পরে আসতেছি একটু পরে।
আচ্ছা স্যার।
Yes, sir. আচ্ছা, সো
স্যার
বেসিক্যালি
এখানে কি
দিস ইজ
শুধু
হোয়াট ইউ গট
64টা এন্ট্রি থাকবে?
হ্যাঁ, আবার
মানে
বলো।
এই যে কলাম ম্যাট্রিক্সটা আছে এখানে কি শুধু মানে ফ্ল্যাটেন করার পর মাত্র
এটা আরো সবার
64
লাস্টে আসে আমরা ফ্ল্যাটেন করবো, যখন
হ্যাঁ
আমরা
হ্যাঁ
এটা সব
মানে
ফিচার বের করা হয়ে যাবে তারপর ফ্ল্যাটেন করা হবে।
হ্যাঁ মানে 64টা ফিচারের জন্য কি এখানে এই কলামে জাস্ট 64টা এন্ট্রি থাকবে, কোন কোন ফিচার অ্যাক্টিভেট হয়েছে এরকম কিছু একটা?
হ্যাঁ, অনেকটা এরকমই আইডিয়াটা, এটা নিয়ে একটু পরে বলতেছি, ঠিক আছে? আচ্ছা, so basically whatever the feature, yeah, whatever the image that you have, you are passing it through this convolution and value operation. Fine, গেল, but not just one convolution and value operation. After we have done through this one feature map, we'll take this one, like one set of convolution and relation, let's say convolution one. This one is going to be passed through another set of convolution and value operation. Okay, let's say this is convolution two. So that means এই অ্যাক্টিভেশন ম্যাপের উপর আবার অ্যাক্টিভেশন ম্যাপ আবার ফিল্টার কাজ করবে। আর ফলোইং, সো দ্যাট মিনস ইউ হ্যাভ
না
মোর।
আরেকবার স্যার, বুঝছি না।
হ্যাঁ, আচ্ছা, so whatever the original image is, it is passed through your one convolution operation. Whatever the output is, on that output you will perform this convolution operation again through some other filters, other set of filters. Okay, so আমি বলতেছি আস্তে আস্তে আসতেছি, then on this one you will perform this convolution operation, whatever the result is, you perform the convolution operation again. So multiple convolution operation is going to be performed. This is called hierarchical learning. It is very difficult to মানে কনসেপ্টটা মাথার মধ্যে ইয়া করে একটু কঠিন, একটু আস্তে আস্তে ওয়েট করুন। হায়ারার্কিক্যাল লার্নিং বলা হয়। তো বেসিক্যালি the idea is, you see low level kernels that you have, that means on the first convolution, second convolution যেগুলো আছে, low level kernels, they are going to learn low level features. Low level features is like, এই যে একটা ছোট একটা লাইন, এটা কোনটার মতো, এই যে ওয়ানে আমরা এটা ভেবে লিখি না, এই প্রশ্নটা, থিংস অফ লাইক দিস ওয়ে। দেন এই যে কার্ভ লাইন, আমাদের মনে করো যে আইব্রো, ওকে, এই স্মল, এই যে নোজ শেপ, এই যে এরকম আছে কিনা। সো দিজ আর লাইক ভেরি লো লেভেল ফিচার্স, and when you keep doing this again and again with later kernels, so later kernels, these are called high level features. They are going to learn some high level features. High level features is like, after all those things are summed up and packed together, joined together, high level features looks like this. Okay, two eye side by side, so that means there is eye feature activated there, or a nose feature is activated there, something like this. Okay, so high level feature, or you have some ear shape, something like this. So depending on, or a long tail shape, things like this. So low level features or high level features are like something much more descriptive. High level features are much more clear of this, the idea. So basically, whatever the image is, you are passing through different kernels and different features get activated. The lower level kernels, earlier layers actually learn low level features and they get joined together. In the later layers, they are getting joined together and you are learning more high level features joined together. You are learning more features, high level features like this. Acha. Before you go there, yeah. So whenever we are doing that, there is another operation that's called the pooling operation. Acha. What is the pooling operation? আমরা এখানে দেখছিলাম, এটা দেখছিলাম। So you see, can you see the screen?
Yes, sir.
Acha. So you see, this is loopy pattern filter. It is going to find a 1 there, 9 and 6, like this, something like this. So this is what a loopy pattern filter look like. So see, this is a koala. Okay, this is like an eye detector. It is working as an eye detector. So there are multiple correlators, multiple eye detectors are there. Then you have hands detectors, the filters. A filter weight গুলো আমি একটু পরে বলতেছি. So then you have this like this. So these are the feature maps. You are passing through multiple filters. So you have multiple feature maps like this. Okay, so after these things are combined. When you combine, you see for head combination features. It's like, is there a head or not? Okay, so for a head, there should be some eye there. There should be a nose pattern there. There should be an ear pattern there. If all three exist, that constitutes a weight, constitutes a head. So the lower level kernels will give you this. When they are summed up together in the higher level kernels are summed up like this. So a head exists or not. If a head exists, that means this is sort of an animal. So that's like one of your high level feature. Okay, this is what is actually happening in the background. Are you following? Idea
Yes, sir.
একটু করে বুঝতে পারলে হবে, সমস্যা নেই। So similarly, whether a body exists or not. So if you have a hands or legs, that means body exists. Okay, so your convolution operation is actually working like this. You see the feature extraction part. You have these lower convolution, higher convolution. এই যে অনেকগুলো পুলিং দেখো এখানে কনভলিউশন স্লেডো, কনভলিউশন রেলো যাচ্ছে they are actually joined together. সেই জিনিসটাই দেখানো হচ্ছে. So basically all of them join together. Finally, when you are in the last stage, then you flatten it. When you flatten it, that means whether it exists or not. So that is the flattened matrix. That is what the features actually looks like. One dimensional features. Then you can actually run it through a neural network, artificial neural network before you go there. Acha, let's look into some. So there are many other filters. There are many types of filters. ওগুলো নিয়ে দেখে নিও, সমস্যা নাই। এটা আমি পরে দেখাচ্ছি। প্যাডিং পরে আসতেছি। রিলো তো আমি অলরেডি বলছি। পুলিং, আচ্ছা, পুলিংটার কাজ। Let's see what does the pooling does. So you see, look at this left side. If you perform a 2x2 pooling, okay, 2x2 filters. আচ্ছা, so what is the maximum from here? 8. তাহলে 8 চলে আসলো। What is the maximum from here? 9. তাহলে 9 চলে আসলো। Maximum from here 3 চলে আসলো, 2 চলে আসলো। So basically, whatever the input is, it is now actually given to a lower dimension. Lower dimension হয়ে গেছে না?
Yes, sir.
স্যার এটা তো স্যার রেলু অপারেশন না স্যার?
না, পুলিং রেলু তো হচ্ছে পজিটিভ অথবা জিরো নেওয়া। পুলিং হচ্ছে তোমার ম্যাক্সিমাম ভ্যালুটাকে নিয়ে আসা, ম্যাক্সিমাম পুলিং, ম্যাক্স পুলিং বলা হয়। সো
স্যার এটা কি স্যার রেলুর পরে করব?
এটা রেলুর পরে দেখো,
এই জি স্যার।
এই যে কনভলিউশন প্লাস রেলু তারপর পুলিং, কনভলিউশন প্লাস রেলু তারপর পুলিং। ওকে,
জি
সো
স্যার।
ইফ দ্য অরিজিনাল ইমেজ ইজ সাইজ 4x4, কি হয়ে গেল নাও ইয়ার সাইজটা, আমার ডাইমেনশনটা কি অর্ধেক হয়ে গেল না? 2x2 হয়ে
জি
গেছে।
স্যার।
So look at here. If I use a pooling of 2x2 filter, then this is এটা আমি অলরেডি দেখাইছি। আচ্ছা, so basically what you're doing, you are passing it through like প্রথমে কনভলিউশন, দেন ভ্যালু, তারপর পুলিং। আচ্ছা, এটা আরো কিছু কারণ আছে, আমি আর পরে বলতেছি, বিফোর ইউ গো দেয়ার। So basically you see, if the 9 was in this image here, or in the left side, or in the right side, ultimately after this convolution, then হচ্ছে pulling, ReLU, then pulling, the output matrix is going to be something similar, right? Similar হবে না? বোঝো
জি স্যার।
হবে কিন্তু, তাই না?
স্যার একটু রিপিট করেন এই পার্টটা।
স্যার বুঝি নাই স্যার।
আচ্ছা বুঝাচ্ছি, দাঁড়াও এটা একটু আবার খাতায় আসি।
তো এটা কি কম্পিউটেশনাল কস্ট কমাই দিচ্ছে এই
হ্যাঁ,
জন্য?
কম্পিউটেশনাল বলতেছে একটা একটা করে, দাঁড়াও। সো পুলিং এর কাজ হচ্ছে, লেটস সে ইফ ইউ হ্যাভ এ ম্যাট্রিক্স লাইক দিস, আফটার 2 by 2 পুলিং আমরা এটাকে এইটুক করে দিচ্ছি, অর্ধেক করে দিচ্ছি। বাট আমরা শুধু অর্ধেক, উই আর জাস্ট মেকিং ইট হাফ। ওকে, ইফ আই হ্যাভ এ like a 100 by 100 image, we are converting into a 50 by 50 image. But max pooling means we are not only just making it half, but also highlighting the features. Okay, we are highlighting the features যেখানে আমার ইয়ে আছে. So we are not just actually pulling it down to some lower dimension, but we are also in this process, we are also highlighting where the feature is. So basically, if I go back, if you look at here, so these values are 0. These are no features. এই ভ্যালুগুলো 0, এগুলো তো ফিচার না. This is 1. These are values. These are important to us. So when I'm pulling down, I am letting it go, but highlighting this the presence of 1. When I'm pulling, I'm letting it go, highlighting this presence of higher value. So whatever the higher value that is getting highlighted when you are performing this pulling operation. Is it clear?
Yes, sir.
Okay. So basically, when you are doing this pulling operation, number one task is the dimension is reduced. Okay. The features get highlighted. So this is better. That means any features that is not very good or not very clear to you, that gets omitted after pulling operation, and any feature that is good to you, that gets highlighted. And behind these two, there is another important fix, that is this help you the position. আচ্ছা, what is the position? আবার অ্যাটেন্ডেন্স লেখা শুরু করছে, আমি অ্যাটেন্ডেন্স লিখতে বলছি। Now let's say in this image your 9 is exist here. In this image 9 exists here. Rest of things are 0, for instance. In this image 9 exists here. Think of it like this way. All the images, are they the same thing? Same thing now?
No, sir.
Yes, sir.
Just 9. So think of it like this way.
Sure.
When you are given an
Yeah,
image,
sure.
the position of a cat is irrelevant to you, because cat can be located anywhere. Okay. But you have to identify the cat irrespective of the position. You have to identify the presence of 9 irrespective of the position. So position does not matter. Are you following? So
Yes, sir.
one of the important, like one of the very critical part of image is that your algorithm must not be depending on position. Where it is located doesn't matter. Whether it is located does matter. So it has to be position irrelevant. Okay. This is where ANN fails. ANN is position dependent, because depending on position, it can change. But when you're performing convolution operation, then perform followed by ReLU, then followed by max pooling, this becomes position irrelevant. How? Because when you are pulling it, this will be 0. তার মানে কি এগুলা সব ছোট হইতে থাকবে। This will be 0. এগুলো সব 0 হইতে থাকবে। This will be 0. আলটিমেটলি এইটার জন্য আমার যে আলটিমেট যে ফিল্টারটা আসবে, এই ফিল্টারটা হবে এরকম 0 0 let's say 1, এই ফিল্টারটা হবে 0 1 0 0, এই ফিল্টারটা হলো 0 1 0 0, something like this. Ultimately the lower side, the features will be highlighted, and most of the things will be, and the surrounding part will be 0. Any zeros, most of the zeros, they will be removed. Most of the zeros will be removed because they are lower value. Are you following? আমার কথা কি বোঝা যাচ্ছে?
Yes, sir.
So whenever pulling it down, you see, whenever you're pulling it down, this is going to remain, these are going to be reduced. So whenever pulling it down, this is going to be reduced, this is going to be reduced. Whatever you reduce it, the feature is always exist. Okay. So when you are reducing the dimension, let's say whenever you are reducing the dimension, আস্তে আস্তে যখন কমতে থাকবে, জিরো গুলো কমতে থাকবে, ফিচারটা তোমার এক্সিস্ট করবে অলওয়েজ। So feature is going to be there. So that's what the benefit of max pooling is that wherever your object, wherever it is located, performing the pooling operation, it is making it down in the lower dimension, but the feature is going to be remain important to you, relevant to you. It is going to be highlighted. The irrelevant positions, irrelevant is going to be omitted. So making the algorithm position irrelevant. Okay, or এটাকে বলা হয় স্পেশাল ইনভেরিয়েন্ট। এটাকে বলা হয় স্পেশাল ইনভেরিয়েন্ট। স্পেশাল মানে হচ্ছে স্পেসের মধ্যে। So the space does not matter. It has to be a spatial invariant. Okay, this is one of the most critical part of algorithm, CNN algorithm. Okay, the algorithm needs to be a spatial invariant, and this pooling operation allows you to do that. আচ্ছা, are you okay up to now? Any question?
তো রিলেটিভ পজিশন তো সবসময় সেম থাকবে পুলিং
হ্যাঁ,
অপারেশনের পর,
রিলেটিভ পজিশনটা তোমার ঠিক থাকতে হবে। হ্যাঁ,
বাট স্পেশাল ইনভেরিয়েন্ট বলতে বোঝানো হচ্ছে যে যে কোনো পজিশনে থাকুক না কেন এটা ডিটেক্ট করতে পারতেছে।
হ্যাঁ, যে কোনো পজিশনে থাকুক না কেন এটা ডিটেক্ট করতে পারতে হবে। আমার কাজ হচ্ছে ডিটেক্ট করা, আমার পজিশন দেখা নয়, পজিশনের রেসপেক্টিভে নয়, যে কোনো জায়গায় থাকতে পারে। আমার হচ্ছে অবজেক্ট আছে কিনা সেটা হচ্ছে ডিটেক্ট করা। ঠিক আছে,
জি স্যার।
ক্লিয়ার আপ টু নাও? আচ্ছা, লেটস গো ব্যাক। So if I go back here, okay, so you see, this is an image of a koala. This is also an image of a koala, but both of them are in a very two different position. One is sitting, another one is sleeping. Can you see it properly? Okay, so basically your goal is whether there is a koala or not, irrespective of the location. So you see, you are finding eyes and nose, you are finding head and body after these final layers, and you see here, location is different. One features are activated, but whether the feature is activated or not, that is more important. Okay, not the location. কোথায় আছে সেটা না, সেই জিনিসটা হচ্ছে। So when you are designing your algorithm like this, convolution operation followed by ReLU followed by max pooling, the output that you are getting is something like this. Okay, whenever there is a feature there, it gets activated. No feature, it is not going to be activated. It is the basic idea. Any question up to now? Any question? আচ্ছা, so after this multiple convolution and filter layers, convolution যাচ্ছে, pooling যাচ্ছে, filter হওয়ার পর, so in the last stage, okay, last convolution, last pooling, সবার লাস্টে যেটা আসবে, after this one you perform flattening. Flatten means ওই যে বললাম, this is horizontal flattening, it can be vertical flattening, and again basically the two-dimensional or three-dimensional whatever you have, it has to be converted into one dimension, because then you can actually connect it with the neurons. For the neurons, we need one-dimensional value, okay, for the ANN part. So after you flatten it, these are the feature values, then it is going to be connected with the ANN, or a fully connected layer. Okay, this is the architecture, what it looks like. Any question up to now? Acha. For the final layer, you see the output classes. So in the output classes, how many categories are there? That many neurons would have to be there. Why? Because you see here, if you have three categories, you need three neurons in the output layer. Each one will give you the prediction for every one item. Okay, so if you have 10 categories in the output layer, কতগুলো থাকবে neuron? How many neurons are going to be there? 10 neurons. So basically এই জিনিসটাকে বলা হয় softmax layer. The softmax layer gives you the probability distribution like this. It's basically the sigmoid function just extended into multi-class. Okay, sigmoid is for binary, probability 0 and 1 এর মধ্যে binary. Softmax is multi-class, same thing but multi-class. That's the difference. Okay, so after your classification, that's the entire design actually looks like. Okay, any question? So basically, you see, this is your image. You are passing through convolution layer, filters. Then you get the features. Features gets highlighted, get flattened, then ANN, then prediction task. This is one because you are predicting whether it's a koala or not. That's why you have one. If you have 10 categories, you have 10 there. 1000 categories, 1000 neuron will going to be there in the output layer. Okay, any question up to now? Any question? আচ্ছা, নাও সি এখন একটু আসি, এখানে এখন দুইটা ইস্যু আছে এখনো। আচ্ছা, two issues. What are those issues? Now, so আচ্ছা, ফার্স্ট থিং, দ্য ফার্স্ট থিং ফার্স্ট। আচ্ছা আচ্ছা, আগে ফার্স্ট থিংটা করি। কম্পিউটেশনাল computational complexity is a big issue when it's about images, because image can be very big. Okay, so images are very large in dimension, processing takes a lot of time, so computational complexity is a very big issue. You want to reduce the computational complexity. Okay, if you have a ANN, the computational complexity is extremely high. Okay, that's why we don't want it. We want CNN, the computational complexity is reduced, significantly reduced. Okay, how it is reduced, that's what we are going to see. Acha. So let's say, for instance, we have the convolution operation at first, then we have the ReLU operation, then you have the pooling operation. Okay, Acha. And a combination of these three is going through one time, two times, three times. It can be repeated multiple times. Okay, fine. Then আরেকটু পরে বলতেছি। আচ্ছা, when you are performing the convolution operation, the original dimension of the image, was it reduced? ছোট হয়ে গেছিল কি?
Yes, sir.
একটু ছোট হয়ে গেছিল, right? Yes. For the ReLU, did the dimension reduce?
Yes, sir.
No.
Yes, sir.
আবার দেখো, রেলুতে ডিমেনশন রিডিউস হয়েছিল, হয়নি।
Pulling for the 0 বা 1 actually.
ReLU is just making it 0 or 1. ঠিক আছে, whatever the dimension is, exactly the same. Okay, it is just converting the value. If it is negative, it is 0. If it is positive, it is positive. Dimension was not reduced. Dimension of the image remains intact. So ReLU is not changing the dimension. For pooling, the dimension was reduced. Okay. For only these two part, the dimension gets reduced. Achha. The question is how much dimension is getting reduced? That's the first question. Achha. And how it is getting reduced. Achha, let's see. First of all, think of it like this way. The original image, let's say it is 28 by 28 image size. Okay. Actually, কি বলছিলাম ভুলে গেলাম। আচ্ছা ঠিক আছে, ওটা পরে আসতেছি। Now, let's say the original image is your of size 28 by 28 multiple by 1. 1 is for grayscale image. Okay. So if it is a 3, then it would have be a কি বলা হচ্ছে RGB image or color image. But whenever you are processing in CNN, most of the time, almost all of the time, we convert the color image into grayscale image because we don't want to consider the color information. Okay. We want the position information, object position, not the color. Okay. So for all CNN architectures, you will find that you are working with grayscale image. Okay. It is important because not color. Color is not the pattern here. The object location, that is what is important to us. Now, if you pass it through a convolution operation, ঠিক আছে? আচ্ছা, so the convolution operation, some things will be mentioned to you. What kind of convolution operation you are performing? First of all is the filter size. Filter size. Okay, what is the filter size that you are actually doing? So let's say we are working with 5 by 5 filter. So previously এখানে আমরা কত ফিল্টার ইউজ করছিলাম দেখো, এখানে কত ছিল?
3 by 3.
3 by 3, right? So filter size is what is the size of the filter? So that will be given to you 5 by 5 filter, for instance. Acha. Then how many filters? So number of kernels, that means how many filters or kernels you are using. Okay, let's say this is 16. বুঝো, এটা একটা math problem, so try to understand. So first, in the convolution operation, the filter size will be mentioned to you. How many filters you are using, that will be mentioned to you. Two other information. One is the stride. Okay. Let's say stride is equals to, let's say 1. So what is stride? আচ্ছা, আরেকটা হচ্ছে padding. Now, padding. So what is stride actually? Stride is, you see, from the image. Okay. So this, let's say this is our first filter and kernel operation. Okay. In the next step, আমরা কোথায় যাব? এইখান থেকে এখানে যাব না?
Yes, sir.
So it's a sliding window. This is called stride হচ্ছে 1. Okay. Instead of going like this is the first position, in the second position was this. যদি এইটা করতাম, ঠিক আছে, তাহলে স্টার্ট কত হইতো?
2.
2। ইজ ইট ক্লিয়ার? আমার কথাটা বোঝা যাচ্ছে? সো এই পজিশন থেকে এই পজিশনের ডিস্টেন্সটা আমরা যদি এক ডিস্টেন্স করে আগাই ইন দ্য পিক্সেল, ইন টার্মস অফ পিক্সেলস, সো দ্যাট ইজ স্ট্রাইড 1। আমরা যদি দুইটা করে আগাই দ্যাট উইল বি পিক্সেল, স্ট্রাইড হবে 2 স্ট্রাইডস। ওকে, আবার বটম
স্যার
বটম
একটা কোশ্চেন ছিল,
হ্যাঁ বলো।
অবজেক্টের সাইজে কি কোনো ভেরিয়েশন কারণে কোনো চেঞ্জ হয়? লাইন আমি ছোট করে লেখা তারপর বড় করে লিখি।
তোমার কথাটা বুঝতে পারতেছি না, আরেকটু।
অবজেক্টের সাইজের উপর কোনো ডিপেন্ড করে? আমি লাইন যদি ছোট করে লিখি অথবা বড় করে লিখি?
অবজেক্টের সাইজের উপর ডিপেন্ড করে কিনা, তাই তো সেটা বলছো তো?
জি স্যার।
হ্যাঁ, অবজেক্টের সাইজের উপর ডিপেন্ড করে। সো ইফ দ্য অবজেক্ট ইজ ভেরি, দ্য ইমেজ ইজ ভেরি লার্জ। আচ্ছা, ওটা আমি একটু পরে বলতেছি, আমাকে একটু পরে মনে করাই দিও, আমি ওটা তারপর বলছি। আমি ম্যাপটা দেখাইনি, তারপর আমি এই জিনিসগুলো ক্লিয়ার করে দিচ্ছি, ঠিক আছে? একটু মনে করাই দিও। আচ্ছা, নাও, সো again in the bottom side, if we go from there to there, if I just go from one step, it is going to be a stride 1. If it is 2 step, I'm going to go like this. Okay, so that's what is called the stride. Now, so if we, in the previous example, we have stride, use stride is equals to 1, right? ঠিক আছে, stride 1 use করছি। What is padding? Padding means, you say this was your image, this was your original image, থাকলো, and when we perform the kernel operation, আচ্ছা আগে এটা দিয়ে করাই, ধরে নাও হচ্ছে প্যাডিং ইয়া করে করাই। Our output equation is going to be something like this. W is equals to, sorry, W out, output side is going to be the input size minus the filter size plus 2 into padding divided by the stride plus হচ্ছে 1. Okay, okay. So what is my original input size? 28 না? 28. What is my filter size? 5. Let's say padding হচ্ছে 0, কোনো padding আমি ইউজ করলাম না। Let's say p is equals to 0 থাকলো। স্ট্রাইড হচ্ছে কত? 1 প্লাস কত হচ্ছে 1, তাহলে এখানে কত হবে বলো, কত হবে? What will be the value? 24, ঠিক আছে?
Yes, sir.
Yes. So you see, our original image was of size 28, okay. After this convolution operation, our size কি হয়ে যাচ্ছে? 24, সাইজ কমে গেছে। কনভলিউশন অপারেশন করলে আমাদের সাইজ কমে যায় না? একটু আগে দেখছিলাম, কমছে। Are you following?
Yes, sir.
Okay. So remember, previously our original image I think was of size 7. We performed a 3x3 filter with a stride equals to 1. তখন আমার আউটপুট সাইড কি হয়ে গেছিল? 5 হয়ে গেছিল না? ঠিক আছে না?
জি স্যার।
হয়েছে? So basically, when you using a filter like this, your size gets reduced. Okay. Basically, the size -1 this amount of time. If we don't use any padding. আচ্ছা, what is padding? Padding means, you see, if we don't
Sir,
want, হ্যাঁ, বলো।
স্যার এখানে তো ইমেজ সাইজ 28,28, কিন্তু যদি মনে করেন 28,20 থাকতো তাহলে
তাহলে
ডাব্লিউ কত
প্রত্যেকটা জন্য
নিতাম?
করতে হতো, 28 এর জন্য করতে হতো, 20 এর জন্য করতে হতো, আলাদা আলাদা করে।
আচ্ছা,
Okay,
জি স্যার।
I will give you like this so the computation becomes easier. So you see, through this convolution, if we did not want the dimension to reduce, so what we do, we can add a layer like this outside. Okay, layer like this outside. The values can be like, all the values can be 0. Okay, or whatever the corner value is. If the corner value is 5, you make it 5 like this. Okay, this operation is called padding. Okay, this operation is called padding. You are padding the input image with some value. It can be 0 padding or same padding. It can be 0 padding, same padding, 2 types of padding. So this is the p value. Okay, how many layers of padding you are adding? So if you add some padding like this, you see, if we use padding here, then the equation becomes like this: 28 minus 5. There was a 2 by 2 padding. So 2 by 2 divided by 1 plus 1. So you see what is the value becomes 28. Same থাকে না?
জি স্যার। স্যার মানে আমরা যদি স্যার ছবির অরিজিনাল ইমেজটাকে ইনটেক্ট রাখতে চাই তখন সেক্ষেত্রে আমরা প্যাডিং ইউজ করতেছি।
তোর মনে হয় মিউট করা।
স্যার আপনার কথা শোনা যাচ্ছে।
তার কথা শোনা যাচ্ছে না। হ্যালো হ্যালো।
স্যার
সরি, মাইক আবার কখন মুট হয়ে গেল? কতদূর পর্যন্ত আমি বলছিলাম? কতদূর?
ডাইমেনশন সেম
নতুনটাতে
রাখার জন্য
কিছুই
প্যাডিং
বলেন।
করা হয় এই পর্যন্ত।
আচ্ছা, এখানে কখনো উঠে গেল। So basically, if we want to keep the dimension same, we use the padding. Okay, then your size remains same, 28 by 28. As for the filter, এটা বলছিলাম, এটা শোনা গেছে তো?
না স্যার।
So see, after we have signed this one, we have 16 kernels. That means we are going to have 16 feature maps. So the dimension is going to be multiple by 16. So that is like third dimension. You have now same image, 16 feature maps. So that is the third dimension. So the output image size is going to be like this: 28 by 28 multiplied by 16. Acha. Then we go to the pooling operation. In the pooling operation, you have the filter size of 2. Okay. Stride is 2. That means jump step is 2. Pooling is 0. Usually, no pooling is done in, sorry, কি বলা হচ্ছে? Padding is 0. Usually, no padding is done. এটা তুমি assume করে নিবে। In max pooling, we don't do any padding. So this is always 0. So what is the size becomes? +1. এখানে একটা +1 ছিল। So the size become 14. Okay. So the output image size is going to be from here to here. It is going to be 14 by 14 by কত হবে বলো? 16 or 8?
16।
16 or 8? হ্যাঁ, 16 or 8?
16.
16. Yes. it is going to remain 16 because you see, this is a third dimension. This is the image size. We are reducing the image constant. We are considering the image features, not the number of kernels. Okay, so this is going to be the image size. So after one convolution, one pooling, this is your image size. Then comes your convolution 2. And the convolution 2. What is the kernel? Let's say 32 kernels. Okay. What is the fetal size? Let's say 5. What is the stride? Let's say 1. Padding is 2 padding. Okay. So if you perform the calculation again, so since we are adding 2 padding, so it is going to remain the same. Only the kernel is going to change. From 16, it is going to be 32 kernels because now we have 32 features from here. Okay. Then we go to pooling 2. In the pooling 2, again, the filter size is 2 and the stride is 2. So the output is going to be 7 by 7 by 32. Okay. Is it clear? Any question? Any question?
স্যার এটা কি
আচ্ছা
থার্ড কনভলিউশন?
সেকেন্ড না, এটা হচ্ছে পুলিং 2, সেকেন্ড পুলিং, থার্ড কনভলিউশনে যায়নি, সেকেন্ড পুলিং 2.
জি স্যার।
Acha. So this is how everything actually works. You see, original image size was 28 by 28, which through convolution and pooling, the dimension of the image is reducing and the filter size is increasing. আমার কথা বোঝা যাচ্ছে? So through this convolution pooling operation, the image size is reducing, the filter size is increasing. We try to increase the filter because the filters are actually having the different types of features. So we usually increase the filters as we go and they reduce the dimension to focus on the most important part of the image. Okay. After this one, কি আসবে? আচ্ছা. There are 2 things we can do in this step. We can use another convolution, another pooling. Fine. Let's say we don't go further. We directly flatten it. Okay. If I flatten it, how many neurons is going to be there? So neuron flatten means this 3D matrix is going to become a 1D matrix. কতগুলো ফিচার থাকবে এখন তাহলে বলো নিউরন?
14
হ্যাঁ,
14
7 into 7. No, it is going to be 1568. The flattened size is 1568. Multiplication. সবগুলো মাল্টিপ্লিকেশন, তাই না? ফ্ল্যাটেন মানে কি দেখো,
জি
বুঝে
স্যার
গেছো?
বুঝতে পারছি
আমার যদি এখানে 4টা থাকে, 1 2 3 4, 4/3 ম্যাট্রিক্স হয়, আমি যদি ফ্ল্যাটেন করি আমার সাইজ কত হবে? 3 4 12। ওকে, সো ইচ ওয়ান আমার যদি হচ্ছে 5টা থার্ড ডিমেনশন থাকে তাহলে কি হয়ে যাবে? 60। সো সামথিং লাইক দিস। সো everyone gets 1 neuron, then multiple by this one. So this is going to be 1568. Okay, so you are flattening it. After flattening it, we use a fully connected layer. Okay, this is called a fully connected layer 1. Now, you can use one fully connected layer, then the output layer separately, or you can use directly, that's fine. Okay, if nothing is mentioned, if there says that there is only one fully connected layer, then they are actually the same thing. Okay, if there is 2 fully connected layer, then it becomes like this. Acha. Let's assume that there is only one fully connected layer. Okay, one fully connected layer means that is going to be the output layer. Okay, so the output layer, let's say the number of classes যদি হয় 10টা, okay, so their output layer কতগুলো থাকবে? 10টা নিউরন থাকবে, there will be 10 neurons there. Okay, is it clear? Are you following?
স্যার
Yes,
একবার
sir.
রিপিট
Sir,
করলে ভালো।
বলো।
স্যার কনভলিউশন লেয়ার 2 তে যে স্যার 32টা স্যার ফিচার, এটা কি স্যার আগের 16টার সাথে যোগ হয়ে 32 হয়েছে নাকি স্যার এটা নতুন
নতুন কার্নেল,
32? আচ্ছা আচ্ছা স্যার,
নতুন কার্নেল
আচ্ছা স্যার।
32টা আসলো, দেন পুলিং আসলো। Okay, see this image again. আচ্ছা, see, এই যে convolution pooling, we are performing this convolution pooling. We have performed two convolution and two pooling. Then we have flatten it. Flatten it, that means 3 dimension becomes 1 dimension. Okay. Then you can have multiple fully connected layer, then the output layer. Okay. So this flattened layer means that many neurons are there. This is that many neurons. Each one is 1 neuron. Okay. So that is we are currently right now. কতগুলো দেখাচ্ছিলাম? এখানে ছিল হচ্ছে 1568. We have seen that there are 1568 neurons here. Then if you want directly to the output without any fully connected layer, that is also possible. That means if there are 3 classes, there are going to be 3 neurons. So this one is going to be directly connected here. Or you can have multiple fully connected layer info. So that is like the hidden layers. Hidden layer পড়াইছিলাম না? মনে আছে? Neural network.
জি স্যার।
So you can add as many hidden layer as you want. Okay. Here currently you have 2 hidden layers. This is the input, this is the output. You can have 2 hidden layers here. You can have 1 hidden layer here. Okay, এটাই বলতেছিলাম। Clear? এখন so basically share করি। So basically after flatten, if you directly go to output, that means they are connected directly. So there is no hidden layer here. So that is, it's fine. If you want to add a hidden layer there, obviously you can. So hidden layer যদি দাও তাহলে কি আসবে? Let's say you can have 100 hidden layers. So this 1568 neurons is going to be connected to this fully connected layer. Then you have the output. Then from 100, it is going to be 10. Okay. The natural convention is to have 1 hidden layer. Okay. General convention. Usually we use 1 fully connected layer here. Okay. Acha. Is it clear now how the math is done? Any question? So this is how you actually connect them all together from the initial position, okay, from the initial image going through multiple convolution filter operation, and that's where your output is actually located at the end. Acha. Now, so the problem with using a filter fully connected layer, you see, if I use 100 fully one fully connected layer with 100 neurons here, so how many weights are going to be in this connection? কতগুলো থাকবে? 156800, right? There is going to be that many connection because all the neurons are connected to all the other neurons. So এখানেই কয়টা চলে আসছে? 1,56,800. So with just one fully connected layer, you are adding that many weights. Okay. So that's why you want to keep the number of fully connected layer limited because they actually add most number of weights. Okay. Computational complexity will increase. So you keep it as minimum as possible. আচ্ছা, গেল। So এখন কি কি কোশ্চেন জানি বাকি ছিল? ওয়েট, হ্যাঁ, আরেকটা কি কোশ্চেন ছিলাম বলো? সাইজ কি জানি বলছিলাম, কি জানি কোশ্চেন ছিল, কি একটা কোশ্চেন করছিলাম আমাকে। হোয়াট ওয়াজ দ্য কোশ্চেন? সাইজ নিয়ে কি জানি একজন কোশ্চেন করছিলাম, ভুলে গেলাম। যাই হোক, আচ্ছা। So try to learn this math. Okay, the example is actually given in the article that is provided on the notebook. Hasan sir article টা ওখানে পাবা, ওখানে একটা ম্যাথ দেওয়া আছে. Try to do this math. Now one last thing, you see, so basically you have whatever you have seen, we have the image. Okay, we are passing it through multiple convolution neural network, and then we are classifying. Acha. So what we are learning here, this CNN neural network, this neural network is learning. Previously, we have seen the ANN actually learn weights. So what this neural network, convolution neural network, where are the weights? Where are the weights? So basically, you see, when you are passing the image through different convolution operation, okay, that connection, that is where the weights are related. So you see, this is like a supervised learning. That means for a cat to identify it as a cat, what kind of kernel do you need? That are the weights. To identify, let's say, a book, what kind of features that you need. Okay, that is what is being learned in the training process. Okay, the kernel values, the weight values that you are going to learn in the process, that is what the feature learning is in the middle. So you want the kernels, but what are going to be the values that is being learned during the training process. Okay, that's where the weight values actually comes from. So during this training process, after we try to predict some of the features, what features do you need? What are the most suitable features? That is actually learned. What makes the cat a cat? You try to find, you are feeding multiple images, let's say 1000 images. You are trying to find some common ground. Okay, what are the common features that is actually belong to cat? That are the weights that are being updated here in the middle. Okay, যাই হোক, আর ভালো হচ্ছে। Any question? Any more question? অনেক হয়েছে। অবজেক্ট সাইজের উপর ডিপেন্ড করে, ইয়েস, অবজেক্ট সাইজের উপর ডিপেন্ড করে। ইউ সি ইন দিস লেয়ার, ওকে, when your output size is 7, 7, and 32, you have 68, right? That is the flattened layer. So that means after one fully connected layer, you are going to have this amount of neurons there. That means this amount of weight you have to learn. Okay. So if the original size, you see the original size is something like 300 by 300, that is the lowest size usually. So that means if your image size is higher, you need multiple convolution and pooling layer to gradually reduce it down. যদি if you don't reduce it down significantly, তখন কি আসবে? লাস্ট লেয়ারে মনে করো তোমার আসলে 100 by 164. So what is going to be the output after flattening? What is going to be the output? 640000. That means 64K. Okay, 6 লাখ, almost 6 লাখ নিউরন তোমার এখানে চলে আসতেছে। Then if you currently connect it with another fully connected layer with 1000, that means it is going to be 640000 with 2 more zeros, 3 more zeros. That many weights that you have to learn, that is extremely high. So the computational complexity going to be significantly high. So we don't want like this. So through this multiple convolution operation, we keep reducing the size, making it very small. Okay. So for instance, one of the algorithm that you have learned that was called VGG16, বলছিলাম। VGG16 means there is going to be 16 convolution layer. So whatever the original size is, it is going to keep reducing it down in some level, so that before you go to the last step, before flattening it, your image size becomes very low. Okay, then your parameters become low. So in this CNN architectures, you see the number of parameters that you learn, it is around in the level of 100 million. Okay, that many weights you have to learn per epoch. Okay, when you are training. So this is extremely huge. Okay, 100 million weights. That means to identify what a cat makes it a cat, not a dog. That means that amount of weight that you actually learn, that amount of parameters that you actually learn. So that is extremely large. Yeah. CNN নিয়ে 2টা ক্লাস লাগতো, বাট আমি নিশ্চয় শর্ট করে রাখতে সেই জন্য একই ক্লাসে বেশি হয়ে গেল। So basically the CNN actually works like this. Basic আইডিয়াটা বুঝতেই হবে। ইমেজের ক্ষেত্রে you try to learn from the image through this kind of operations. Okay. আচ্ছা, আর লাস্ট আরেকটা জিনিস একটু মনে পড়লো। Okay, so another thing, last thing. So you see, one approach is flattening it. If you flatten it, it goes like this. Another approach is pooling. এটাকে বলা হয় global average pooling. Okay, or GAP. Instead of using flattening, if you use global average pooling, the output size is going to be 1 multiplied by 1 multiplied by 32. For each of the kernel, you are going to get the maximum value, okay, or average value. So here it is GAP, so average value. So the average of these values will be there for each kernel. So the size is going to be 32. That means that after you flatten it, it is going to remain 32. It is going to be reduced. So some cases for some architectures, global average is pooling is used instead of flattening. Okay, fine. শেষ। Any other question? কারো কোনো question? Long class. Okay, you can write your student ID.